To have a quick look at this graph from a very recent review from last month in Natural Review Materials that tries to summarize what could be different value chains when it comes to the valorization of plastic. And today I'm going to focus this presentation on renewability. That means the fact that plastic can come from a biological source, and also I will focus on end of life that regards aerobic composting or biodegradation in aerobic environment. And in doing so, I'm going to talk a little bit about biopolymers and bioplastics and these value chains. So when it's important to know, and I believe that most of you already know that renewability regards the origin of a given material, while biodegradability regards the end of life. And this aspect could be either interconnected or not. It depends on many different factors, and we'll talk a little bit more about that. But what is, I believe, really important is that the choice of a biomaterial for a specific application need to be coupled with the end of life. And one of the reasons is that the sustainability should not be should be assessed on the overall value chain and not on a specific step, on the specific application or a specific material. Let me give you an example. When it comes, for example, to organize a large fair, if you think, well, let me say, pre-COVID and pre-pandemic, you have to provide food catering to a large number of people in a really small amount of time and space. And one option is to use food service products. What's the advantage of using a biodegradable and compostable solution? Well, if you look at this data, it is not related to the production step, because to produce biodegradable and compostable cutlery and the polystyrene cutlery in this specific example has quite the same amount of kilogram of CO2 equivalent emitted. But since the end of life is composting, then you divert all the organic fraction collected into industrial composting and not landfilling. And that results in a negative contribution of CO2 equivalent emitted by the conversion of organic waste into compost. And thus, the overall amount of CO2 equivalent emitted is just a little bit higher than 20 kilograms rather than 60. That tells us there is a 1/3 of kilogram CO2 equivalent emitted by adopting a biodegradable and compostable cutlery in this kind of value chain. Exactly. Now, my point is FDCA is a monomer. Is a bio-based monomer, not just any monomer. It's bio-based monomer that is characterized from the scientific point of view by the fact that it's quite rigid. But I will not I'm not talking as Patrizio from NOVAMONT, and talking as Patrizio as an organic chemist. This is not a replacement of terephthalic acid, and the main reason is that furan dicarboxylic acid has a furan, and the furan you should treat like that. It is not, for me, a drop-in to terephthalic acid, and PF is not a drop-in to PET.
Yeah, no, that's
not
for sure.
in my personal scientific opinion, though this is a bio-based monomer which can be obtained at industrial scale. Avantium is demonstrating them, it, NOVAMONT also. Let's take advantage of that, but designing a sustainable value chain where all the properties that you mentioned, for example, in specific case, barrier property regarding gases or water, and regarding whatever, they could be explored.